My name is Caroline Cardonel. I am a field application scientist for molecular devices. And in today's short video, I'm going to show you how to set up an AlphaScreen assay in SoftMax Pro. This cartridge is compatible with the SpectrumMax i3X and with the SpectrumMax paradigm. Let me give you some specification about that cartridge. What you need to know about the cartridge is that it has an excitation filter at 680 nanometer and an emission filter at 570 nanometer with a broad bandwidth, which will allow you to read the AlphaScreen emission and the alpha LISA emission. The cartridge will be installed from the top, and you will have a light blocking tube that will go down onto the plate in order to reduce the crosstalk. It is a laser diode based cartridge to allow a strong excitation. You have three types of cartridges. You will have the 384 standard, the 384 HTS, and the 1536 HTS. The main difference between the standard and the HTS is the time it takes to read the plate. With the HTS, it will take half of the time that it takes for the standard cartridge. Nevertheless, the assay window and the detection will remain the same between the two cartridges. Now, how to install the cartridge? So in order to handle the cartridge properly, you need to make sure that the two clips are up, so you can just plug the cartridge onto the pins. In addition, you have to make sure that you don't put your fingers onto the filter of the emission. So here, you will have to open the drawer. You take the cartridge, you leave the pin, and then you will plug the cartridge onto the pin. You have then to plug the pins properly and close the drawer. This is done in a few minutes, and then your system will be AlphaScreen compatible. So now how to set up your protocol in SoftMax Pro. So first of all, you will see that you have a protocol that is available in the protocol library. So you go into the protocol manager, protocol library, binding enzymology, AlphaScreen, and you click on the protocol. It will open the default AlphaScreen protocol, which has all the settings that you will need to read your plate. But here, you will see that the default settings that are entered inside the instruments are going to be linked to the cartridge, either if it's a standard or an HTS. So for the HTS, it's 40 millisecond excitation, 80 millisecond integration time, while it's 140 and 280 for the standard cartridge. Those are the standard value. If you want, you can also enter optimal value. This means that it will take longer to read the plate, but you will have an improved signal to noise ratio depending on your plate, your buffer, and your setup. But this can be achieved. The results you will obtain with the standard values are perfectly fine, but the optimal value will make sure that you get really the best signal to noise ratio for the experiment. Then you will need to do two optimizations: the plate dimension optimization and the labware optimization. So for the first step, so the plate height optimization, in the instrument instrument settings, you will have to select the second line in the navigation tree, the plate type. Once you select the plate type, you're going to be able to edit the plate. So you can choose a format, 384 or 96, depending on the plate you are using. And the important information that you have to enter is actually the plate height. Please adjust this value so it meets the height of the plate you are going to use. And this is very important because it will make sure that the light blocking tube will go down onto the well, making sure that it has a small distance between the well and the blocking tube to reduce the crosstalk with adjacent wells. The second optimization is a labware optimization. And this is to make sure that you will align the emission with the excitation with the emission beam. You need to put a solution in the four corner, and it can be either the AlphaScreen standard or the OmniMids, and it's just to make sure that you have a positive alpha sample in the four corner to generate a signal. This alignment needs to be done for 96 alpha area, 384 well plate, and 1536 well plate. It is critical that this step is done before you do an experiment. So to do this, again, in the instrument setting, you will have to select the last line in the navigation tree, More Settings. Show Period Optimization has to be selected. Once it's selected, you can click on OK. And once you're going to click on Read, you will see that the first window that will appear is a period optimization option. You have to select Run Microplate Optimization and then Run Optimization. This optimization can take up to 10 minutes in order to be performed. So you will put your plate with the solution in the four corner, and you click on Next, and then the system will ask you to optimize individually each corner. So you can have one of those windows where you have a nice shooting target and you have to realign the pink cursor with the center of the well. But it does happen with AlphaScreen that sometimes the signal you're getting is a bit fuzzy, and you have to realign again the pink cursor with the center where you have the strongest signal. Once you have optimized the four corners, you will have this final window that will show you the offset of each corner. You can then click on Save, and you can also rename the plate if you wish, but please make sure that you keep the alpha landscape optimization in bracket to know that this is a plate you will need to use in the future. This optimization does not need to be done every time. You just do it once at the beginning and then reuse that plate that has been optimized. So now I'm going to give you some recommendations. And the first one is going to be the interlace reading. So the interlace reading can be selected again in the More Settings window in the instrument settings. And if this interlace reading is selected, then the plate will be read like a chessboard. What it means that first the instrument will read all the black wells in like a snake, so reading A from A1 to A12 and in B from B12 to B1 and so on. And then once the plate is finished, it will come back to A2 and again read all the white wells like a snake. What does it mean for you? It means that you will reduce dramatically the crosstalk coming from adjacent wells. If this interlace on is selected, you can see that it's actually taking 15 seconds more to read one plate. But the advantages are incredible. You will see that you will decrease dramatically the crosstalk, and the crosstalk can be decreased from 10 to 15%. You will get much lower CV, mostly for lower concentrations, and you will get better curve with a much better R-square. So the interlace on is really a must option to choose. In addition, we do recommend that you use plates that are recommended to improve the emission signal, such as white or gray plate. This is making sure that you're reducing the crosstalk from neighboring well. In addition, be very careful when you handle the plate. You need to work as much as possible in the dark and to make sure that the plate is dark adapt before you read the signal. What does it mean? It means that every time the plate is incubating, put it in a drawer, and before you start the read, put the plate inside the machine, wait for a minute or two, and then you can start reading. Also, the alpha kits are temperature sensitive, so make sure you work with a constant temperature if you want to compare data. And as I say, the interlace reading on is really a must if you want to decrease the crosstalk. We have several application notes that are available on our website, but now let me show you how to set up the AlphaScreen assay in SoftMax Pro. So in the software, you can see that I have the i3X that is selected. And if I want to get my protocol, I'm going to go to Protocol Manager, Protocol Library, Binding and Enzymology, AlphaScreen 384 HTS. Here you will have the protocol, that will appear, and then I can just amend my document in order to read the plate. So the first thing is selecting the plate section. Here I'm going to have the setting that have been entered for a 384 well plate with the HTX cartridge. And I can amend this if I want to by clicking onto the acquisition settings. In this window, of course, the optimal configuration will depend on the cartridge that you have installed. Here in the wavelengths, you can see that everything is grayed out because we're using dedicated filters that are within the cartridge. I select the plate type, and here I'm going to be able to choose between 96 or 384 well plate. I'm going to edit the plate, and here you can see that the value I need to change is the plate height. And I will need to adjust it to the height that I have been given by the plate manufacturer. Then I will select the area that I wish to read, if I need to select less than the whole 384 well plate. PMT and optics, I can either choose the standard PMT options or the optimal that we have seen in that presentation. We generally don't shake with the AlphaScreen, and then I can go into the more settings window where I'm going to be able to choose first the pre-read optimization to optimize the labware, and then the interlace reading. I can then click on OK. Once I have clicked on OK, I'm selecting read, run optimization, run optimization. Here I'm going to put my plate with the four corner containing a positive alpha signal, and I click on next. Because my instrument in simulation here, it will be much faster. But remember, this will take 10 minutes, more or less 10 minutes, and the plate can be saved to be reused afterwards. As it is in simulation, here I have a very clean signal, but you can see that I can realign that pink cursor onto the center of my well. So enter to realign the pink cursor where the signal is the highest within the well. I click on next, and I can do this for the four corners. And then I will have the new offset dimension, the name of the plate, and the optimization that was done with the Alpha cartridge. I can click on save, and my plate is ready to be read. Here, it's going to, again, it's reading much faster than it is in simulation mode, but the plate will have been read with the interlace on, meaning that we'll have better CV, less crosstalk, and a better curve fit. The data can then be analyzed as you wish. You can create those response curves, and you can plot them very nicely in the software in order to generate your standard curves. Please don't hesitate to contact us if you want more information, if you want a demo, or if you want a training on how to use the cartridge to generate AlphaScreen data. Thank you so much for listening.